Hi, welcome to the IntroStat lecturing series. And we are in the unit testing hypothesis. And this is our lecture number 7. And in this lecture, we are continuing the hypothesis testing, but now we switch to testing the population mean. Okay, so what's that means here? Let's go ahead and start. And let's go to our lecture note. And then let's start to work on that. Okay. All right. So we started this lecture. We talk about is the population means, right? So what's that mean? For our previous, the hypothesis testing, we said we're testing the population proportion. That means like the example we used, we said, hey, the percent of the smoker, right? So if this population has the 30% of the population are smoker, and also we say, hey, this new drug, what is the percent survival rate for this new drug, right? So for the previous lecture we talked about is we want to know some information about the population proportion. And now start this testing hypothesis, we want to know something about the population mean. So what's that means? That means that now instead of say, hey, I'm looking for what is the percent of the smoker, I would say, hey, I want to know what is the average GPA for all the university, for all these like the Dallas area universities, what is the students' GPA, average GPA? What is this city's average income, right? So that's why we are talking about is more, right now instead of the proportions, right? So we're going to talk about the population means here. And also we said the population mean, we use a Greek letter, we use like a, look like a U, but we pronounce like a mu, okay? So we said that we want to testing the population mean, or you can say that it's kind of like a mean, the other word for mean, maybe it's easier for you to understand is we call it is the averages here. Okay, so for the hypothesis testing, so just like an average, just like a proportion, we have the null hypothesis and we have 3 different alternative hypotheses here. Okay, so the null hypothesis here is mu is equal to what? Mu 0. That means the population mean equal to specific number. So like right now, I want to test it, what is the average family income, for these cities? And I think, the average income maybe is 65,000, right? So if I want to test, is the average income 65,000, then my mu 0 is like what? It's 65,000, right? So the mu 0 is the specific value you want to test about, okay? So just like we did before, we have the 3 different alternatives here. So we say the mu is not equal to mu 0. That means I think the family income, the average income is different than the 65,000, right? Or you can have the otherwise, here the mu is greater than mu 0 here. Or just like we did for the proportion, you can have mu is what? Is less than mu 0. Am I right? Okay, so this is the two side, right? This is, we call this a two-tail test, right? Because it's not equal. This is one tail, and because this is greater than, so this is right tails, right? And this is one tail also, but this one is less than, so we call this left tail. So like we did it before, so the, just like a proportion, we have not equal, greater than, or less than, right? Okay, now for the proportion, for the population mean, the test statistic is a little bit different. For the population proportion, we have in the lecture 4 and 5, we say we use the what? We use the one proportion z-test, right? Okay, so in here, for the means here, you will have two test statistics. And here, the keyword is when the population sigma is known or population sigma is unknown, all right? So if the sigma is known, then we are using what? If sigma is known, we are using z-test. If sigma is unknown, I'm using t-test here, okay? So let's take a look. So let's take a look at the first one. Let's write it out. So if the sigma is known, so it will be z-test, right? So we say the z is equal to what do we have here? We have this is x bar minus mu 0. Then we have a sigma over square roots of the n. So what is the x bars here? This is your sample averages, right? So whatever you want to test, so like we talk about, we say, hey, I want to test, I want to test what is this city's family incomes, right? So I will go to take maybe 60 families and ask them what is their annual income, and I average it. So that's what we call it, it's just sample average. And the mu zero, this is the specific value we want to test in our hypothesis, right? Then here, this is a sigma. This is the population sigma they're giving you here, right? Okay, now what is the n's here? N's here, this is the sample size. So it's like say, hey, I want to find for this city, I'm taking 60 families. Then the n is equal to 60 here, okay? So now, if the population sigma is unknown, then we say, oh, we're going to change it to a different test. We call it the t-test. We're going to talk about the t-test in more detail in the later of this lecture. So what is the test statistic? Still is very similar, is x bar minus mu 0. So instead of the sigmas, right? So because sigma is unknown, so now I'm using the s divided by the square root of the s here. So in here, the x bar, just like before, still is what? The x bar still is the sample averages, right? And now I have then the mu 0 is the same thing, like the number you want to test. And now I have what? These things here, the S here. So what is the S here? S, this is, we call this the sample standard deviation. And the N is what we call is the sample size here. Okay, so now let's take a look at the critical values here. And so for the critical value, let's take a look at this is the one I'm going to, this is a critical value for the what is a z-test here, right? Then I'm going to show you how to find the critical value for the, how do you find the critical value for the t-test here, right? So for here, let's take a look. Let's do a table here. All right. So this is my significant level. So this is a 10%. And now this is what is your HAs here, right? So we know we always have 3 different HAs. So this one's here is true tail. U is not equal to mu 0. And this is mu greater than mu 0. And then this one's here is mu less than mu 0. Okay, let's take a look at this one. And then you'll be able to find the other one by yourself. Okay, so this is the critical value. I put it here. Okay, so those are the critical values. So this is 1.64 or negative 1.64. And this is 1.28, and this is negative 1.28, right? Okay, I'm going to show you how do I find those values here, okay? And we know this is one tail, right? So the two tails was, the two tails we did it before, right? The critical value going to be what? Going to have two tails, right? So going to be this tail and this tails, right? And then if you have one tail here, so if it's right tail is here, okay? And then if this is a left tail here, right? So left tail is here. Okay, now I'm going to show you how to use the table because we already covered this in the lecture number 6 here. Let's say this is a 10% here, all right? So this is the 10%. Let me show you the table way. So if you want to use your table, so here, and at the end of your book, the tables here, this is the Z table, right? Because we're using the the first things here, right? So be careful here, since we are using the Z-test, right? So this is the Z tables here. So make sure you know that. Okay, so now let's take a look. We said, okay, so we said we have two tails and one tails, right? Okay, so we said, okay, so let's take a look. How do I get a 1.64? So this is my two tails here. That means here, here, right? And I have a 10%. So two tails, you equally divide it. So how much is each one? Each one is 5%. Oh, it's 0.05. And this one is 0.05, right? Then you look your tables here. You look your tables, take a look at your tables here, right? So the table value is this shaded value, see here, all right? So now let's see if we can find it, okay? So in here, they said it's a 0.05, right? So I better clear that one out so we're not, okay? Okay, so it's a 0.05. Let's go here, right? Okay, so it's a 0.05. So you find the one very close to the 0.05. Okay, so let's see here. All right, so 0.05, 05, 0.05, 05, 0.05. See here, it's 1. So this is 0.0495. This is 0.05. 0505. So it's give you what? It give you is 1.64. So sometimes you can say 1.64 or 1.65, doesn't really matter, all right? And so the same way, a while ago, we said one side, right? So for the one side is 10%, right? We said one side here, a while ago we said if this is one side, then this side will be 10%, right? 0.1. So let's take a look, 0.1. Which one is very close to the 0.1? Oh, this one, right? 0.1003. So what is this one's here? This is 1. What? 2, negative 1.28. Right? Then if you're looking for the right-hand side, because they are symmetric, so you will get a positive 1.28. Did you see here? That's how do you use the table to find it. All right. So let's go back to our lecture notes here. So if you cannot remember this, that's fine. As long as, you can go to the table, you know how to use the table right now, right? So you shouldn't know because we did a lot in the lecture number 6. So let me just try to write it down. The most frequently used one, like the 10%, 5%, and the 1%, right? So this is mu greater than mu 0, and this is mu less than mu 0. So this one's here, if you want to write it, you can write it. This is 1.96 or negative 1.96. It will be a lot easier than you know, if you don't want to write it, you can always go to the table and find it. This is 1.64. This is negative 1.64 here. And then the same things here. If this is 1% here, right? And then let's see here. This is HA. And then this one's here is mu is not equal to mu 0. And mu greater than mu 0. And HA, mu is less than mu 0 here. All right. So if you do that, and then you can, you can go ahead and so now you can find the critical values here. This one will be 2.58, or if you want, is negative 2.58, and this is 2.33, and this is negative 2.33, right? Because they are all symmetric, okay? Then the last things we say, the p-value. We said the p-value typical is difficult. So I'm going to show you how to use the TI-84 calculator for the, or you can use the R, try to find the p-values here, all right? So this is all about this is all about the z-test here, right? Okay, I'm going to show you an example, and I'm going to skip the t-test here, and we're going to come back here. Okay, so let's take a look at these examples here. This is the first example in this lecture. They tell you the average college student goes through 500 disposable cups in a year. To raise the environmental awareness, a student group at a large university volunteered to help count how many cups was used by students to their campus. So let's try to highlight all the information. So a random sample of 50 students, they find, all right? So they find they have a mean and 476 cups. And with the sigma 42, all right? So at the alpha equal to the 0.1, is there sufficient evidence to conclude mean is different from, right? So the mean is different from the 500 cups here. Okay, so for here, okay, so let's see here. So the non-hypothesis here, what is the non-hypothesis here? Will be the mu is equal to 500 cups, right? And now let's say it says you want to test the mean different. So what is my alternative hypothesis? Alternative hypothesis is not equal to the 500s here. Okay, now you want to see, okay, so you say, okay, this is a population test for the mean, right? Now, which test I'm using? I'm using the z-test or I'm using the t-test. So you're searching through the information, then you say, oh, for here, they give us here, the sigma is equal to 42. And I know what is this sigma? This is the Greek letter notations, right? So I know this is the population standard deviation, the population sigma. So it's known or unknown. So it's known, right? So it's a given. So what test I'm using? I'm using what? Z-test, right? You see here, that's why you say, okay, in here I'm using the z-test. The reason why it's here is because the population sigma is given, it's known, okay? So now I can use my z-test. So now I will have the, okay, so now let's, in order to get my information, so this is mu 0, and then it's sigma over square root of n, right? Okay, so now let's take a look here. Okay, so let's take a look here. And so this is x bar minus mu. So what is mu zero? Mu zero, this is our 500th here, right? And so what is x bar? X bar is the average, right? So x bar is the average from what? From the samples, right? So what is my average here? Is 476 cups here. Then the square, so what is the n's here? N is the sample size. So what is the n's here? It's 50. So now let's plug this one here. It's 476 minus 500. And what is the sigma? 42 over square root of the 50s, right? So let's take a look. So it's 476 minus 500 is negative 24 divided by 42 divided by the square root of the 50s here. All right, so let's see what is here. We get is a negative 4.04. Okay, so so it's a negative 4.04. For this one, you don't really need any special software to help you. Okay, so now if I want to, if I don't have I just want to find the critical regions, right? So these ones here, they tell you, you know, the alpha is 0.1, right? So let's take a look at what is my critical region. We just talked about if I don't want to find the p-value. Now I'm going to go to show you how to use the TI-84 to find the p-values here. Okay, so here, this is because we say it's not equals, right? So this is not equal. So it's a both tail. So from just we talked about before, like we, you know, we wrote it down for the 10% and it's not equal. So what is the critical values here? Is 1.64 and the negative 1.64, right? Right, so it's a 10%, it's not equal. And then now you have a test statistics. Here is negative 4.04, so has to be somewhere here, negative 4.04. So what is in here? So you will say the Z is in the rejection region, right? So what do? So we reject non-hypothesis here. So you can do all the way, and then you can make a conclusions here. But now if you want to, you know, right now, if you want to know how to find the p-values here, right? So if you want to know how to find the p-values, and then you can use the TI-84 calculator, or you can use the, you know, the R code to try to help you see here. Okay, let me show you how to use the TI-84 calculator here, right? So let's go to the TI-84 calculator. If I can find where is my calculators here. Okay, so let me see here. All right. Okay, so wow. So it doesn't want to, let me see here. Okay, let me go find it again. So my TI-84 calculator, I got it. All right, so here you should be able to see this is my TI-84 calculator, right? So clear that out. So let me show you how to do that, all right? So turn that on. So you might want to write down the step, right? So you do statistic, STAT, stat. Click that. Then you go to test. And this is what type of the test? This is Z-test, right? So you choose the number 1, Z-test. Then you hit enter. Okay, so you want to use the statistics, right? Then you go down here. So what is your mu zeros here? 500, right? And see here, they automatically give you the sigma. So what is the sigma here? Is 42, correct? Okay, now here, the X bar here is the sample average. So what is here? 476. All right. Now, what is the sample size? 50. All right. And now you are testing how many tails? Both tails, right? So it's mu is not equal to. Then you go down here, you do the calculation, and then see here, you will see, okay, so you will see here how the Z statistics, right? So exactly like what we calculate, right? And now the p-values here, p-value is 5.33 to the e to the negative 5. What's that mean? 5.3 because this means is 0.0000533. That means if you move the decimal point like 5 places, right? So this is 1, 2, 3, 4, 5 will give you, 5.33. So that's what, so when you read the calculator, be very careful about this E, all right? All right, so let's go back to here, go back to our lecture notes here. So now we also find the p-values, right? So we can find the p-values here. Okay, so when you find the p-values and what is the, what is the values here? We just did is 0.0000533. Wow, this is what is a lot less than my critical value 0.1. So do you have the same conclusion? Yes. What is the conclusion? Reject H0s, right? So reject H0s, that's good. So now to reject H0s, okay, so let's try to write down the conclusion. We said the conclusion is very important. Reject, that means what is, we support the claim, right? So we said data provides, so data provide significant evidence to support what? HA, right? To support the claim. So what is HA? Is not equal. So you need to write it down. What you're supporting, right? To support the claim that the student, right, used, let the student, so what are the, so find the mean, sufficient to collect the mean. Okay, so let the student use the average, let the average student, average cup, right? So average cups student used is, is different than what? Is different than 500 cups here. All right, so we're going to reach the same conclusion. You either use the critical region or use the p-values here, right? Okay, so like now we know how to do the hypothesis testing for the z-test, right? So we have been using the z-test for the proportion, testing for the population proportion. All right, so now this is a good place to stop. And our next video, we're going to talk about how to redo the population test when the t, when the sigma is unknown, then we're going to use the t-test. And what is the t-test? All right, so we're going to talk about it in our next videos here. All right, okay, bye. Have a good day.